This is Laura Duncan from CSMS. Today we'll be graphing quadratic equations. Let's begin by describing the changes in the quadratic parent function for each equation. Let's look at the quadratic equation here. Remember that if it's on the outside of the parentheses, this changes from the parent function by either going up if it's positive or down if it's negative. However, if there is a plus or minus inside the parentheses, then that will be a left or right change. And then the coefficient outside of the parentheses or in front of the x squared will tell us whether parabola faces upward or opens downward. Now let's take a look at the first one. Notice that it says that there is plus 4 and it's inside the parentheses. So counterintuitively, plus more actually means that it will be left 4. Let's look at the next one. The next one has minus 3 and there's no parentheses. So that means that it will move the parent function down 3 from 0, 0. Notice on number 3, there are two changes. One change is that we have minus 2 inside the parentheses. Counterintuitively, that means that we would move right 2 from the linear parent function. The second change is that 1 is added. Now that means that it will go up 1. And those are the two changes. Try number 4 on your own. Please pause the video here. Number 4, the changes to the quadratic parent function would be left 3 and up 2. Now let's look at number 5. It shows minus 4 inside the parentheses, so that would be a movement of right 4, and then minus 2 would mean that it moves or shifts down 2. Now in number 6, I want you to notice how many transformations there are. So I see 3. Right here, that coefficient in front of the parentheses means that this function, this parabola, will open down. Another change is inside the parentheses where we have plus 5, and that means that the parabola will shift 5 to the left. And lastly, we see that we have minus 6 outside of the parentheses, and that means that it will shift or translate down 6. Number 7 and 8 have coefficients, numeric coefficients other than 1 or negative 1. So let's look at number 7 in comparison to the quadratic parent function. Since the coefficient is a number that's greater than 1, this means that the function will stretch or will become more narrow. Now looking at number 8, how many transformations do you see? One of the transformations is this negative, and that means that the function will open downward. We also see that x squared is being multiplied by 1/3. It's not just negative 1/3. So that 1/3 implies that it will be compressed or be wider. Finally, we'll be writing equations for each graph. Now what I want you to remember is the quadratic parent function. We have values at 1, 1, 2, 4, and 0, 0. And remember, the axis of symmetry goes through the vertex. That helps us draw our function. So this is the original quadratic parent function. From there, we can see that it has shifted over 1, 2, 3 to the left. Secondly, it has shifted down 1. Now let's see if it is just as wide or just as narrow as the original. So 1 away should be 1 up. And it appears that it is the same width as the original parent function. So we're going to start with our y equals. Remember, since we went left 3, that's going to be inside the parentheses. We don't square the x because the square will go on the outside of the parentheses. Since it was left, we're going to have plus 3 inside the parentheses. And the down 1 will be minus 1 outside of the parentheses. This is the equation for that function. I'd also like you to note that this is the vertex form of the equation. Notice that the vertex is at -3, -1. Now notice how the vertex and the equation have many matching points. If it moves down 1, it will have the same. However, if it moves left 1, remember how it's counterintuitive? So inside the parentheses, it will be the opposite of the vertex. Now let's take our notice to number 10. How many transformations do you see? Please pause the video here and list them. Now it may also help you to notice that the vertex is 2, 3. That may help you in writing your equation. So first of all, let's start with y equals. Since it opens down, that means that we're going to have a coefficient of a negative outside of the parentheses. Inside the parentheses, you're going to have an x. Do not square the x because the square will be outside of the parentheses. Since it's moving right 2, we'll have x minus 2. And finally, since we're moving up 3, that will be plus 3. So compare that to the vertex. Now for number 11, how many transformations do you see? One is that it opens down. And from the origin, it has shifted up 1. Be helpful to you to note the vertex, which is at the point 0, 1, and it is a maximum point. This is where students make mistakes though. We only have those 2 transformations. One is that it opens down, so we know we're going to have a negative coefficient. But here, this is where students make the mistake. They forget to square the x. Remember, this is a parabola, so the x will be squared. And then finally, it shifted up 1, so we do plus 1 outside of the parentheses. Look at number 12. Try number 12 and 13 on your own. Please pause the video here. On number 12, we see a shift of left 1, down 2, and a vertex of -1, -2. So in this case, the function will be y equals, open parentheses, x plus 1, don't forget the squared, and then minus 2. On number 13, there are 3 transformations. The 3 transformations are that it opens down, moved right 1, and moved down 1. So our equation would be y equals open parentheses. Don't square your x yet because you're going to move right, which means that you're going to take away 1 and then square outside the parentheses. We're also going to move down 1, so that means subtracting 1 outside the parentheses. So since it opened down, we're also going to have a negative coefficient outside of the parentheses. That concludes your lesson for today.